This is a quick review of some formulas from coordinate geometry. Here I have a line segment with endpoints P is at 5, 1 and Q is at 11, 9. One question they could ask is what's the length of PQ? And the secret to the length of a line segment like that is to imagine a right triangle and to do the Pythagorean theorem. This point here in the bottom right hand corner is 11, 1. It has the same x coordinate as this point, the same y coordinate as that point. The length of the legs of these triangles, this one is just 9 minus 1, which is 8. And for this horizontal line, it's 11 minus 5, which is 6. So horizontal lines, vertical lines, are easy to find the length of because you just subtract the either the x coordinate or the y coordinate. So according to the Pythagorean theorem, this is the right triangle. It's the square root of 6 squared plus 8 squared, which is the square root of 100, which is 10. The official formula for distance is the square root of x2 minus x1 squared plus y2 minus y1 squared, where it doesn't matter which one you call, point 1 and point 2. I'll just call this x2, y2, and this one x1, y1, as long as you're consistent about it. Another property of line segments is slope. Slope is how steep the line segment is, how much up it goes for every 1 unit to the right. And a slope of 1 would be a nice 45-degree angle. This seems to have a slope of greater than 1. And some people like to say rise over run, or y2 minus y1 over x2 minus x1. y2 minus y1, this is the same points as before with the 5, 1 and the 11, 9. So y2, we still have the 8 and 6 from before, so the slope is going to be 8 over 6, which reduces to 4/3. So this line has a positive slope. It's going up from left to right, and its slope is bigger than 1. A concept related to slope is the angle. Any two lines that intersect form an angle. And in this case, this line is only one line here, but if I were to extend the line, it would form an angle with the x-axis. And depending on which side, there's also, I'll just call this theta 1, there's also this obtuse angle, I'll call theta 2. Finding these angles is quick. First observation is that this line makes an angle with the horizontal x-axis. Well, it makes the same line with any horizontal line, and I'll use this one that goes through point P. Because what we have here, the same right triangle we used before with the 8 and the 6 that we used for calculating out the distance, the length of PQ, and also the slope of line segment PQ, we could also use that to find angle theta with the fact that the tangent is opposite over adjacent, 8 over 6. And then on the calculator, you can do inverse tangent as 8 over 6 to learn that this angle is about 53 degrees, and that makes this angle also about 53 degrees. The obtuse angle, if they wanted to know it, would be 180 minus 53, which is about 127 degrees. So we have these two angles. In general, the tangent of the angle is equivalent to the slope of the line segment. When we see an equation with an x and a y, like this y equals 2x equation, this is an equation that has a solution set. For instance, 0, 0 is in the solution set because it's true that if I put 0 in for x and 0 in for y, it's true. But there are other ordered pairs in the solution set. They all have in common that the y-coordinate is double the x-coordinate. And when I graph these all, 0, 0, 1, 2, 2, 4, etc., we end up with this line segment, it goes through the origin, it goes through 0, 0, and its slope is 2. So for every 1 unit to the right, we go 2 units up, 1 to the right, 2 units up. So an equation of this form, y equals mx, will definitely have 0, 0 as one of the infinite points in the solution set. Now if I give you an equation like y equals 2x, and let's say I tell you that we have these points 0, 0, 1, 2, 2, 4, I'll throw in another one, 3, 6. We can answer questions about other equations that are related to this original equation. For instance, what if my equation, instead of saying y equals 2x, says y minus 7 equals 2 parentheses x minus 4. So I can even put parentheses around here to make it more clear. You see, both of these equations have something is equal to 2 times some other thing. In that way, these two equations are related to each other. And I could actually find ordered pairs in the solution set. So here I've got 0, 0, 1, 2, 2, 4, and 3, 6. So here are 4 points that are in the solution set for this original equation, y equals 2x. I'm going to find 4 points in the solution set for this other equation. Now the trick to this is, let's go 1 point at a time. If 0, 0 makes this first equation true, then that means 0 equals 2 times 0. So I have to think, what numbers could I put into this other equation that lead to that same fact that 0 equals 2 times 0? And the answer is 4, 7. See, if I put 4 in for x, I get 0. 2 times 4 minus 4 is 0. And if I put 7 in for y, I get 0. So again, 0 equals 0. I can do the same thing, and I'll actually plot this point here for 7. I can do the same thing here with the point 1, 2. It's a fact that 2 is equal to 2 times 1. So if I put numbers into this other equation so that it becomes 2 equals 2 times 1, it would be 9 minus 7 is 2. And for the x here, I have to put in 5. So there's a second point, 9. Sorry, got that backwards. I meant 5. 5, 9. Which is over here. And this third point, the 2, 4 point, I need to put something into the x so that it becomes 2, so that's 6. And then the y thing has to become 4, so it's 11 minus 7, which is 4, so 6, 11 gets me another point. And just for one more practice, 3, 6. Now there's all kinds of points on these lines, on the second line, but I want to just do the 4 that are kind of related to the 4 in the first line. So to get 3, 6, I need to put 7 in for x. That turns x minus 4 into 3. And I need to put 13 in for y, so that it becomes 6 equals 2 times 3. And when I connect those, I see I have this line that's parallel to the original. Notice how every point in that line has moved so that it is 4 to the right of what it normally what it used to be, and 7 above. This is going to lead us to something called the point-slope form of a line. In the point-slope form of a line, we have an equation that looks like this: y minus y0, which would be a number, m would be a number, x minus x0. When I put numbers in for these three things, I get something that looks like this. And the idea is, the slope of the line, this has the same format as like y equals mx. But y equals mx goes through 0, 0, whereas this other thing does not go through 0, 0. But they both have slopes of 2, because it's always, this one would be like y equals 2x. So what I like to do is I first think, okay, what leads to the 0, 0 fact? And that would be 7, 4, which is this point right here. So the starting point, I meant 4, 7. So when we see something that has this form to it, one of the points is going to be x0, y0, which in this case is 4, 7. That's the point. Then the slope is just going to be from that point. We're going to take whatever the slope is. In this case, the slope is 2. So from that point, I go 1 to the right, 2 up, 1 to the right, 2 up. And that's how you graph the point-slope form of a line. Here's a practice question. Y plus 2 equals 3 times x minus 4. In this case, the point is going to be positive 4, negative 2. You kind of take the opposite of each of these numbers. So negative 4 becomes positive 4, positive 2 becomes negative 2. And I graph that point, 4, negative 2. And then this number is the slope, so I go 1 to the right and 1, 2, 3 up. 1 to the right and 3 up. I can make a graph of that. Here's an example where I give you a picture of a line and ask for the equation. If we want to use point-slope form, this is x0, this is y0, so it's y minus 2 equals m, which I'll leave blank for now, times x minus 5. And the slope is just counting from this point to the next point. I know I have to go to the right 2 and up 3. The run is 2, the rise is 3, so the slope is 3 over 2. A challenging problem in coordinate geometry is to find the distance between a point and a line. Now, distance between 2 points is pretty easy, but from a point to a line, well, it's possible that there's more than one answer, because I can get to this line from this point many ways. But we've decided that there is only one answer to this question, and it's going to be the shortest distance from that point to that line, which also turns out to be, if you make a line segment from the point to the line, it would make a right angle. And one of the challenges that we do on the first homework assignment is to try to figure out, there's about 5 different ways to get the distance from this point to this line. You can work on trying to figure out that answer a couple of different ways. So again, this time the point's going to be 4, 7.